Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 10th, 2025, about 2 days ago. It introduces a unified diffusion transformer system that can both generate layered Photoshop PSD files from text and decompose a single flat image back into editable, transparency-aware layers, which is something standard generative models really struggle with. The paper is titled OmniPSD, Layered PSD Generation with Diffusion Transformer. And as we will see later, this bidirectional control over layers could seriously change how designers and models collaborate on complex visual layouts. Figure 1 shows how the system turns between flat posters and fully layered Photoshop PSD files. On the left, a user asks the model to extract text, foreground, and background, and the central grid of tiles displays the decomposed layers with transparent checkerboard regions. On the right, a natural language prompt becomes a structured caption, which drives a second layered grid, and finally, a clean, editable, eco-themed poster. Together, these examples highlight that the same diffusion transformer handles both text-to-PSD generation and image-to-PSD reconstruction. Figure 2 explains how the system actually achieves layered PSD editing in both directions. The panels on the left show an RGBA variational autoencoder and diffusion transformer block that learn a transparency-aware latent space, so alpha channels stay intact. The central sequence illustrates image-to-PSD, where the model repeatedly erases text or objects and extracts them as separate transparent layers. On the right, text-to-PSD starts from a structured prompt, generates a grid of latent layers, and then restores clean, editable text by re-rendering fonts on top. Figure 5 shows that this system not only keeps up with strong image generators, it also delivers much cleaner, editable layers. The left block compares text to PSD results, where the foreground tiles stay nicely isolated and the backgrounds remain smooth, so transparency looks natural. On the right, image-to-PSD reconstruction preserves the original poster while separating text and graphics into crisp layers, which competing methods often blur or leave partially erased. Table 1 shows that this system reconstructs layered posters from flat images much more accurately than prior methods. Here, lower mean squared error means fewer pixel mistakes, while higher peak signal-to-noise ratio, which is a standard image fidelity score, higher structural similarity, higher clip image score, and higher GPT-4 score all reflect better visual and semantic quality. OmniPSD scores best on every metric, beating Context, NanoBanana, and GPT Image 1 by a large margin. Table 2 shows that the system is also the strongest model when generating layered posters directly from text. In this table, lower Friche inception distance means images look closer to real designs, while higher clip score and higher GPT-4 score mean better alignment with the prompt and more coherent layouts. Compared with layered diffuse and GPT Image 1, OmniPSD achieves the best value on all three metrics, so it produces both more realistic and more semantically faithful text-driven posters. Table 4 shows that the transparency-aware RGBA variational autoencoder reconstructs layered images far more accurately than previous variational autoencoders. A variational autoencoder is a compression model that learns to encode and decode images, so better scores mean cleaner reconstructions. Compared with layer diffuse, red variational autoencoder, and alpha variational autoencoder, the new model achieves the lowest mean squared error and perceptual distance and the highest peak signal-to-noise ratio and structural similarity, which together indicate crisp details and well-preserved alpha channels. Alright, wrapping up, 2 takeaways stand out. This work shows that diffusion transformers can natively reason about layers and transparency, and it proves you can go both ways, from text or flat images to fully editable design files. That points toward much tighter collaboration between generative models and professional design tools. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.